As the James Webb Telescope has simply noticed counterfeit light in the world Proxima b, this denotes a historic revelation. The JWST MIRI instrument is fit for identifying huge fake light sources on far-off planets. This is the primary genuine proof of a technosignature demonstrating the presence of smart life structures on another planet. MIRI, a high-resolution infrared instrument, is incredibly delicate to infrared radiation. It can recognize far-off city and modern offices at immense distances. This ability broadens not exclusively to our adjoining framework Proxima Centauri. However, MIRI can distinguish fake light sources and potential outsider urban areas all through the known universe. It sounds fabulous what we can do with our new super telescopes. On Earth or from close to Earth space, we can presently effectively distinguish enormous settlements inside the known universe. We have currently accomplished a work of art with the MIR spectrometer at the JWST, and there is something else to come. Another Uber telescope will be sent off in Chile in 2028, the Very Enormous Telescope ELT, with a 39M fundamental mirror. This telescope will look further and more keen into space than at any other time. We need these specialized developments because our hunger for information about the universe is a long way from extinguished. We are just toward the start of investigating far-off universes, and we truly want instruments like the JWST and the ELT to inspect exoplanets for hints of life. In expansion to the capacity to recognize fake light radiating from huge urban areas in space or extraterrestrial landing strips, we will before long be utilizing a new clear-cut advantage with the ELT framework. We will actually want to identify hints of vegetation on far-off planets. The advancement will continue endlessly in our look for different species in space. We will utilize more and better instruments and devices until we have found and made contact with other life frames. The first counterfeit light source on Proxima b is a second researcher have long longed for. Interestingly, they are utilizing a telescope to look so definitively into our adjoining star framework that spots of life become noticeable to us. A counterfeit light source on the world Proxima b uncovers the presence of innovation and subsequently likewise of some type of cutting-edge life. It sounds insane, however, the JWST could even investigate our own exercises on the planet in view of our light marks. The best telescopes ever would, without any problem, catch the lights of significant urban communities such as New York, Rio de Janeiro, or Beijing. With its fine sensors, it can sift through the fake light tracks of air terminals, huge modern plants, or even space stations from the regular light outflows of the Earth. The equivalent is occurring on Proxima b for the first time. We will have exact examinations in our hands of where life is found, how much fake light it produces, and how motorized the species is probably going to be. We have, subsequently, taken a quantum jump in our quest for life in space. At some point, we will positively have the specialized means to speak with other human advancements, to send messages to Proxima b. They would take over 4 years to travel one way by ordinary means. We would need to pause an additional 4 years for an answer to come back. All expectations are presently nailed to the advancement of the first quantum PCs. Quantum interchanges know neither a decent spot nor a proper time. Whenever we have broken this phenomenal innovation, we will foster quantum implies of correspondence and speak with far-off civic establishments as though continuously. Does that sound like an unadulterated ideal world to you? Then, at that point, hang on close since utopias frequently become insights extremely rapidly. It was 2016 and quite far from the now very genuine period of James Webb when researchers longed for investigating outsider universes. Back then, at that point, a momentous recreation anticipated how the James Webb Space Telescope would concentrate on the external layer of the exoplanet Proxima b in an obscure future. These reenactments expected to examine the planet's air and warm properties. By 2016, scientists were at that point dreaming of seeing whether Proxima b had an atmosphere that was possibly friendly to life. What was an ideal world less than quite a while back is presently reality. At that time, reenactments of Proxima b's one-of-a-kind circle previously showed that the profoundly intriguing exoplanet exists in the habitable zone of its parent star, Proxima Centauri. The JWST will do customary and complete observations of the constantly sides of Proxima b. This planet circles its star in a bound way, similarly as our moon circles us. Proxima b generally has a similar side confronting its star, and one side is dependably in shadow. Reenactments have shown that there should be extraordinary temperature contrasts between the constantly sides of Proxima b. Unless the planet has an atmosphere that redistributes heat, without an air, the day side would be blasting hot and the night side frigid cold. The presence of an atmosphere, on the other hand, would permit heat to be distributed more evenly. This is precisely what we can now figure out, thanks to the JWST. The 2016 reenactments showed even more. There could be a tempered strip in the boundary areas between the day and night sides. It sounds unusual to envision that developments exist on a planet that is half light and half dark, and that these creatures chose a strip that is perhaps a few thousand kilometers wide all over the planet. But it is potential. We really want to continue to open our horizons and possibilities in the hunt for other living things in space. To be entirely certain, we want genuine examination. In 2016, the exact examination of the substance structure of the air of Proxima b was as yet a dream. Today, the JWST demonstrates its inventiveness consistently and shows us definite examination profiles for universes that are sometimes hundreds or even great many light years away. The JWST can perceive marks of water, carbon dioxide, and methane, and has previously made finds. The last comprehensive profile was gotten from the exoplanet K218b, where the JWST tracked down proof of 4 biomarkers in the climate. The more such profiles marks are estimated all over a world, the more probable it is that life could exist there. Particularly invigorating is the expected revelation of ozone, which is viewed as a mark of organic action because it is predominantly delivered by natural cycles in our environment. K218b could accordingly be a possessed world. However, we have not yet tracked down any follows of fake light there. This planet could be an unadulterated water world, but that doesn't imply that it is uninhabited. We need to consider that there is shrewd life in the water, potentially even urban communities, and we need to think about that not all evolved species have fake light. We haven't had the light for that long, but people were at that point shrewd and to a specific degree motorized in ancient times. The JWST detects PL development on Proxima. The James Webb Space Telescope, or JWST, is essentially intended to notice the universe in the infrared reach and complete nitty-gritty otherworldly investigations of far-off heavenly bodies. What the JWST has not yet demonstrated is its capacity to recognize plant development on exoplanets. However, it can possibly do this in our quest for life in space. We should not just depend on techn marks and the discharges of profoundly progressed species. We should likewise search for planets that may, as it were, have plants and creatures or other less complex life shapes. The JWST can give circuitous proof of plant development by examining barometrical constituents and reflected light spectra. Researchers call this procedure vegetation red edge, VRE, spectroscopy. These are otherworldly marks made by the intelligent properties of plants in the close infrared reach. When light goes through the climate of an exoplanet and is reflected by the surface, explicit designs in the mirrored light could show the presence of chlorophyll or other photosynthetic shades. The discovery of such marks is still exceptionally testing. The identification of VRE requires very exact estimations and high goal, which can be impacted by the exoplanet's climatic aggravations and the sign-to-commotion proportion. Although the JWST is intended for such estimations, we are currently starting to use these abilities. Analysts are unquestionably improving at finding and recognizing hints of life in space. We are living in astonishing times, since the JWST has begun an upheaval in space investigation, and this advancement proceeds. Direct identification of plant development or natural action will require future telescopes and missions explicitly intended to look for biomarkers. One model is the Arranged Louvois Telescope, Large UV/optical/IR surveyor. This future space telescope aims, among other things, to inspect the environmental properties of exoplanets with significantly more prominent accuracy and to recognize potential biomarkers, for example, the VRE. Another significant telescope right now being worked on is the TESS, Transiting Exoplanet Survey Satellite.